That's actually for the next part of my problems. We have to find the possible negative eigenvalue and the corresponding eigenstate.
Well, this is how you solve for energy.
Yep. I think I've already done that actually. I get negative m alpha squared over 2h bar squared. But the only thing that's bothering me is like part C of the question asks me to determine rho as a function of E, M and alpha. But I've got a delta x in there. That's a function. Do you know what I mean? Like, I don't know why it's there.
Rho is a function. Really weird. You shouldn't have that.
But like when I look at it, like I don't see where I've made the mistake. I should say that I subbed that into a Hamiltonian.
Second. You look up my solution real quick.
It's because it was funny you said you were actually doing the same problem.
Yeah.
It's been Friday night and like I'm off to see Kevin Bridges, a comedian, tomorrow. But my problems have to be in for Friday, so I'm fucked.
Nice.
Okay, yeah, so what you do, you evaluate the derivative at the plus and minus epsilon. So you know your sine terms go to 0, but your cosine terms become 1. So you just end up, the a's cancel on both sides because side of 0 is just going to be a. And you're going to get, like, k is equal to ma v naught over h bar squared.
V
naught is a in this case. Alpha.
I know. We've got the same answers as you, I think. Obviously different questions.
Yeah. Well, in this case, rho is k, right? We're not...
Rho's k. I don't know why he's made it rho. Just probably to make everything more confusing. Because I've always called it k before, up until this point.
Well, once you solve that, then isn't that part C?
No, because part C is I don't know. Determine rho as a function of EM and alpha. So what I done was see my Hamiltonian that's at the top of that page. I basically done h psi equals e psi, took the derivative of that ansatz, plugged it in, but the delta function remains, and I feel like it's wrong. Because when I solve the last part of the question, I have to discount
It's not. I think it's fine because so rho squared is just like the different k's, right? It's yeah. So yeah. What's happening here is, hold on. I'm trying to make sense of this. I remember that there is a delta if there's such a discontinuity, because there needs to be a delta here.
Right, but you can solve out that delta.
Well, remember, the k is e minus v, right?
So in this case, the potential is alpha times that delta function.
Yeah, that makes sense, because that is the potential.
Well, I guess so. You can solve out the k. I posted a link that shows the actual energy.
I just had the feeling. Although I guess if I was to get rid of the delta x, then it wouldn't be dimensionally
consistent. The thing is, the
it.
Delta function makes no sense outside an integral.
That's why I'm fucking thinking it's weird. Because I read about that earlier on.
This guy solves out the energy. Well, if you have.
I've actually done that. I've literally just wrote it up now.
Yeah.
I think I've done it. It looks the same.
Yeah, you're good then.
If you have a delta function out of an integral, then you've just fucked up somewhere.
Yeah.
But I don't know how the fuck a delta function works, so...
So the delta function works, but so the delta function is defined.
It's 1.
Yeah, so its integral equals 1. Well, it scales depending. So you can move it around. You can scale it. By default, its integral always equals 1. Just look up properties of the delta function. Like, that's all you will really need to know.
Right?
So for an intuition on what it is, think about the Gaussian. You know how the Gaussian always integrates to 1?
The delta function's the same, but at every point by x equals 0, it's 0.
You can define the delta function with a Gaussian.
Yeah, so the delta function is just what happens when you take the Gaussian and make it infinitely tall.
Or infinitely thin is how I like to think of it.
Right,
Mm.
yeah. So they're the same function.
Right, if you take a Gaussian that's normalized, like to change the width of it, you just change that constant that's up there in the exponent. And that also shows up in the normalization thing. So you just let that go either infinitely large or infinitely small, I don't remember.
Can I make it disappear? Aye,
Yeah, look why.
but there's no integral when I'm actually solving that part, which annoys me. Well, fuck it, I'll just tell him that I don't know how to do that, but I basically got it right.
Nice.
Can also ignore the bounds.
I'm looking for the picture that SM posted.
The definitions, the different definitions.
Yeah.
Which is what I have.
There it is. Where is it? There we go.
It's some constant. Real. Positive.
There you go, Hypercube. Just consult that.